go. I'm going to get through this as painlessly as possible. All right, when we complete the square, in order to understand complete the square, you first have to fully understand perfect square trinomial. So let me just review that with you quickly. From here on out, I will probably refer to perfect square trinomial as, how'd you know? Oh, did I? Okay. As a PST, okay, perfect square trinomial. So remember, do what?
All we need to do both P.
Oh, yeah. All right. Remember what that looks like. If the ends are both perfect squares, the second sign is a plus, and then it square dances. This first sign could be a plus or a minus. And by square dancing, we mean, Miss Wilson used to do a little dance with it when she taught it. I'm not going to do it. I don't really know the little dance, but she'd sing the little song and she'd do the little dance. But it was square. Come on, get out of here. Square. So what's the square root of a squared? A. So it's square, square, multiply, and double. That means it square dances. Square, square, multiply, and double. And she doing square, square, multiply, and double. Okay, anyway. If it follows that pattern, then we know that it factors how? How? What does it look like once you factor? A plus or minus. That's right. So what we're going to do is we're going to take some quadratics that are not perfect squares, and we're going to make them be perfect squares. Yes. We're going to force them to be a perfect square trinomial.
Is that like those marriages in India?
Arranged marriages, yes. I know you don't want to be a PST, but you're going to be a PST today. All right, so we're going to take it easy as we get into here and look at this. What if I told you that I wanted to force this to be a perfect square trinomial? What would you tell me needs to go in the blank in order for that to be a perfect square trinomial? I hear 16, 64, and 4. I'm going with 16. I agree with that. Wait, because we're going to try to derive a little formula here. I agree with 36. How, those of you who are getting the correct answer, how do you know that? Remember what it's got to look like, okay? The square roots of the ends multiplied and double have to give you in the middle. So let's go backwards on that. The backwards of doubling is dividing it, right? And the opposite of the square roots would be squaring. So if I take what's in the middle, that's my B, right? And I cut it in half, and then I square it, it should give me what's on the end, right? Because they got to be perfect squares on the end. Remember, whenever you check to see if it's square dances, it's square root, multiply, and double. Correct. And what's 4 squared? Y'all following me? Okay. That is correct, Indius. That is only when there's nothing in front of x, because that in front of x, that a is 1. We're going to make sure that if we complete the square, notice I'm saying complete the square because I'm completing the square. I'm putting what makes it a complete perfect square trinomial, right? If there is something in front of x, we're going to get rid of it when we complete the square to make our life a little easier, okay? Yes, I am, for sure, for sure. Okay, first I wanted to make sure. Now, I call this a good C, and I say, because you know that's your value for C right there, okay? So sometimes you'll have to look to check and see if your C is, check to see if your C is a good C or a bad C. Okay. But sometimes you'll have to check that last term to see. A good C would make it a perfect square trinomial, right? And a bad C would say, nope, you're not a perfect square trinomial. Sometimes it'll already be there for you, and you have to just kind of do that analysis. And let me show you what we're going to do here with it before I delve any deeper, and why this is so handy to have. Okay. What do you notice about the left side of this equation as it sits now? It's a perfect square trinomial, right? I have a good C. My C here is a good one. It's good because it makes it a perfect square trinomial. So if I were to factor this, it factors as x plus 3 squared equals 36. Do you all agree with that? Okay. Why is this easy to solve? You're just sad mapping your way out of it. You see that x is only in here one time? When x is only in here one time, I can just sad map my way out. Which means I can square root factored this as a perfect square trinomial. If you FOIL it back out, it'll come back out. Factored form of that is x plus 3, x plus 3. So this gives me x plus 3 equals, what's the square root of 36? Plus or minus 6. Right? Think about those quadratics, and they're crossing that x-axis twice. And then I move the 3 over. Now be very careful when you move this 3 over, because you need to show that this is the two answers that you have. Okay, so I have negative 3 plus 6 or negative 3 minus 6, right?
So why can't you just say x is equal to 3?
I am. So 3, these are the two places where it's crossing the x-axis. Okay. But notice my solve was super easy because I started out with that perfect square trinomial, right? Yes. Okay. It makes for an easy solve because I can just sad map my way back out of it. Does that make sense to you all on what I did? Okay. Let's say, okay, tell me when you're good. Let's say then that I have this equation. Is that a perfect square trinomial? Can it be, I don't want one that can be factored. I'll keep it. Let's say we don't want to factor it, okay? We want to complete the square. We know we want to complete the square. My first, and I'm going to do you some little steps over here because some things are the same no matter what, okay? The first thing is you never, ever, ever want a leading coefficient. What's a leading coefficient? A, okay? If A does not equal 1, okay? So if it's anything other than 1, you need to get rid of it. How do you get rid of it? Divide it out, right? Now I'm going to show you, this is when we're talking about algebraic solutions, okay? When we get into some graphical solutions, I'm going to show you how to keep that A there, because remember my A in front tells me up, down, skinny, wide, and I need that A there to tell me what it is, so I don't want to just get rid of it, okay? But for right now, we'll get rid of it by dividing everything by it, okay? And by everything, I mean every single thing, okay? Now check your C. Is that C good or is it bad? It's bad, right? So if it's good, I can go ahead and factor and solve. Well, I'm going to move it. The only place to move it is to the other side, right? So now I have x squared, come on, plus 4x equals, and I'm leaving some space here intentionally, okay? Because what I'm going to do is I'm going to fill this space that I've left here, and I'm putting it on both sides with that good C that I'm going to find, okay? But because it's an equation that has to stay balanced, if I add it to the left, I've got to add it to the right. Exactly. So I'm going to find a good C. So using that same equation that I've done, b over 2 squared. Again, I don't have an A because I took care of that in the first step, right? So for this one, my C that's going to make this a perfect square trinomial is 4 over 2 squared. Bless you. You all with me? How does the left side factor? X plus 2 squared equals what? 16. So I should probably say add to both sides. And now we can solve, right? What's the square root of 16?
4.
Plus or minus 4. Now subtract the 2, right? That's exactly right. Negative 2 plus 4 would be 2. Negative 2 minus 4 would be negative 6.
Can you just write out negative 2 plus or minus 4? Like that first?
No, if it's whole numbers, I need you to split them up because we're talking a lot about zeros of the function and where it crosses. That's that perfect square trinomial. That's what we forced it to become, and when you force it to become that, that's how you factor it. Well, not really. If you were to group that, if you were to do x squared plus 4x plus 4, what multiplies to 4 but adds to 4? 2 and 2. So x squared plus 2x plus 2x plus 4. X times x plus 2. Pull out a 2, x plus 2. You'd have x plus 2 times x plus 2. It's just a shortcut, which is the same thing as x plus 2 squared. Yes, but you're going to have to recognize perfect square trinomial. It's a pattern you really, really, really need to memorize so you understand complete the square.
How did you get rid of the A? You said if it doesn't equal
We didn't have an A to start with on this one. We'll do one that does have an A in just a second.
2 squared, you have to get rid of it?
If there was a 2 in front here, we would divide everything by 2, and my equation would become x squared plus 2x minus 6 equals 0, and then I'd complete the square from there. Yeah. Yeah, so it doesn't get confused in being a point versus 2 points. Now, I'm going to push you just a little bit further than this. Yeah.
I don't get why you added 4 to both sides.
Because that's that value that makes it a perfect square trinomial. So remember where we were saying, what would I need to put in the blank to make this a perfect square trinomial? Well, on this side, to make that a perfect square trinomial, I would need it to be 4. So because it's an equation that needs to stay balanced, I put it on both sides. Yesterday and the day before, we talked a lot about factoring and how the factoring gives us the zeros, okay? This form, rewriting a quadratic in this form, gives us something very special, and I really, really, really want y'all to make this connection because it's going to be important for tomorrow. If this is my equation, x squared plus 4x minus 12, right? Graphically, what do you know about it while it's in standard form? But look at that equation. What do you know without doing anything? What do you know about the graph? It's going up. It's a parabola. The y-intercept is negative 12. The width is average, right? Because it's a 1 in front. But that's what that tells me in standard form without doing anything else. When it's in factored form, what do I have? What does it give me? The x-intercepts. When it's in completed square form, okay, watch what happens. Here's what I want you to do. If I have, do we agree? Now I'm going to move this 16 back over. Because initially it equaled 0, right? Find the vertex for me of this original standard form. Quadratic. Remember how to do that? Back when we graphed quadratics? Think back. Exactly. How do you find the axis of symmetry? What was it in the no, what was our completed square form? X plus 2 squared minus what? 16. That's when we completed the square, right? This is the same thing, it's just written another way, and what I asked you to do was take this one and find the vertex.
Why is that minus?
Because it was on the other side, so we started out equaling to 0, so just so they're equivalent,
So now
I
you
wanted
just
to...
put it back into as.
So which equation do you use?
The first, you don't know how to find the vertex on the second one. I want you to find the vertex of the first one. So somebody said axis of symmetry, and you're right. How do you do that? What do you get? Opposite B, so negative 4 over 2 times 1, which is negative 2. Plug it back in for y, right? Negative 2, and I think Indy has gotten it. Did you get the y part? I think that's what you just, yeah. 4 times negative 2 minus 12. This gives you what? Look at my equation in completed square form. Look at my vertex. What do you notice? What is that giving you? Remember, every equation gives you something, whether it's y-intercept, whether it's x-intercepts, or in this case, it's giving me what? The vertex. This is also called vertex form. We took the same equation, right? Wrote it a different way, and it gave me different information. This is a lot. I know this is a lot.
This is how it's going to go.
But you got -2 for that.
I did. That's exactly right, Eliza. So inside those parentheses, vertex form is actually a times x minus h squared plus k. So you take the opposite sign inside. Okay? And hk is your vertex. All right? Huh? It's where we completed the square before. That x plus 2 times x plus 2. It's that perfect square trinomial. How about factored? This one is actually a really easy one to factor. How about factored form? What does it look like in factored form? What multiplies to negative 12, but because this is a leading coefficient of 1, I can shortcut it. What do you notice about those two things? It gives you the x-intercepts. Is that not exactly what I found before when I solved for x? 6 and 2. All of this is coming full circle is what I'm trying to get you to see. What 3? I factored x squared plus 4x minus 12. What multiplies to negative 12 but adds to 4? 6 and negative 2. Okay? So that's giving me the zeros. We're going to work extensively with this tomorrow, but I'm going to do some more examples of complete the square. But I really wanted to just touch on how these formulas are coming together graphically, because tomorrow we're going to really focus on graphing. Yeah. The next one, 3, 5. Yeah. So remember, whenever we are factoring, to find the zeros, I set each piece equal to 0. So when you do that and solve, it changes the sign on there. So it changes the sign. From the 0 to the factor, it changes the sign. All right, let's go to another complete the square. Let's see what happens. Do you see the difference, though, in the graphing and the solving and what I'm doing? I mean, it's kind of the same thing. I'm finding zeros is what I'm doing graphically. Y'all okay on that? Your book does not explicitly teach you intercept and which this would be intercept form because it's giving you the x-intercepts, and vertex form, but you're kind of expected to imply it. And I feel like it's a hard implication if you don't see it. You know what I mean? All right, let's look at another. Let's say I have 2x squared minus 7x plus 5. We're going to do this one together because this one's hard.
You divide the 2.
All right, so the first thing I want is I can't complete the square here with a 2 out front. Do we all agree?
Yes.
Blah, right?
No, we have fractions.
Oh, we are. It's okay, though.
No, they're not like that.
Okay, so I got x squared minus 7 over 2x plus 5 over 2 equals 0. That's what I wanted. Good C, bad C. Why? It's not even a perfect square. You don't even have to look any further than that. It's not a perfect square, so get rid of it. I can only get rid of it by moving it to the other side, right? 5 over 2, yep. If you must. Well, but when you start squaring, it won't be. All right, so to find this good C that I'm going to add to both sides of my equation, I need to take B, cut it in half, and square it. Woo! But it's a fraction, right? So let's think about it. When you cut something in half, you can divide by 2 or, right? And since it's already a fraction, I'm just going to multiply by half. So that gives me 7 over 4. Well, you're going to square it, so it doesn't, I mean, it doesn't matter, but yeah. 49 over 16. It is. It's terrible. I prefer the fractions on these. It's more exact.
It'd be,
Your answer's not going to be right in the end if you start doing decimals and rounding here.
isn't it negative though?
Okay, but you square a negative, you get a positive. Put it in parentheses. All right, here's where we start the work, right? We factor the left side. The left side becomes the square root of the first, which is what? The first sign. And what's the square root of 49 over 16? 7 over 4. Notice here is what you get before you square it. Squared equals, well, I'm just going to tell you right now, I'm going to use my calculator here. So I'm going to do, where am I? Negative 5 over 2 plus 49 over 16. Negative 5 over 2 plus 49 over 16. Math, enter, enter. 9 over 16. I'm liking the way that looks. Both of those are perfect squares. Math, enter. Get what from?
Okay, so what
The right side of the equation. Yeah.
So if we start with the 7 over 2 and do all that, then we can do a graph and
So long as you haven't cut anything off, because at this point, see, my answer is going to be both of them. So if you've rounded somewhere and it's messed you up, you won't have the correct answer. Yeah. I didn't do negative 5. I did negative 5 over 2 plus 49 over 16. But it's 49 over 16, which is bigger than 2.5. Yeah. We're solving. Now, Eliza, if I was putting this in vertex form, yes, I would move the 9 over 16 over, and that would be my vertex, 7 over 4, 9 over 16. But whenever I'm finding x, so I'm finding the x-intercepts, so I have x minus 7 over 4 equals, what's the square root of 9 over 16? Don't forget your plus or minus 3/4, right? What got us really, really nasty throughout has really turned a corner, and it's not so nasty anymore. Add 7 over 4 to both sides, and so I get two answers here. 10 over 4 and 1.
Good morning, Cayman High School. It's time for the morning announcement.
And on your